This is Mr. Ashton going through the Mathematics Unit 1 non-calculator higher tier paper from November or autumn of 2016. As it's the higher paper, I've already done the intermediate paper, and the last 8 questions of the intermediate paper were the first 8 questions of the higher tier paper. So if you want to go back and look at any of the first 8 questions, there's a link below for you to click and just fast forward through to them. We've got a formula list here which we may or may not use. It depends on what questions come up. Okay then, so the first question says, or the first question of higher says, circle the correct answer for each of the following statements. 9 to the power of minus a half is equal to. Now, this is looking for you to understand what the power of a minus means. First of all, the power of a minus means 1 over. Those two things are the same thing. Okay, so to the minus means 1 over 9 to the power of a half. Okay, so the minus has now disappeared in my solution because I've said 1 over instead. The next thing it's looking for you to know is that the power of a half is the same as square rooting. So that will now become 1 over the square root of 9, and the square root of 9 is 3, so it would be 1 over 3. The next question is looking for you to again understand a fractional indice, and the key thing here is to look at the bottom. That will tell you which root you're putting that to. Because it's to the 2/3, it would be the cube root. That's what that 3 means. And then to the 2/3 would mean that we would square this answer. So once we've got this answer here, we then square it. Okay, so the number 8 is going to go in the cube root. So what is the cube root of 8? That's 2. And then we have to square that. 2 squared is 2 times 2, which is 4. Okay, the next question says, question 10, the radius of a hemisphere and the radius of a cylinder are equal. The hemisphere and the cylinders have equal volumes. Calculate the ratio of the height of the cylinder and the radius, or calculate the ratio of the height of the cylinder to the radius of the radius of the cylinder. Right, okay. So first of all, let's draw a cylinder to get our heads around what it looks like. So it's just like a toilet roll tube or a kitchen roll tube. Is this sort of shape here. Okay. Now this is the height of my cylinder, and then going from the center to the outside is the radius. Okay. To work out the volume of that, I do V equals pi r squared times by the height. Okay, so that's the area of the cross section, which is the circle, times by how long it is. For a hemisphere, that is half a sphere, so it's half of like a tennis ball type shaped thing here. Okay, now the only measurement that we can go and add on to that is the radius, which goes from the center to the outside of the circle, but you could also have that radius here as well. This here and this here would be the same length. The volume for that is on your formula sheet. Well, it nearly is on your formula sheet. What we are told is that the volume of a sphere is 4/3 pi r cubed. A hemisphere is half of that, so half of 4/3 would be 2/3 pi r cubed. Now, the next thing to pick out from what we were told here was that they have equal volumes. Okay, because they have equal volumes, I can say that that formula there, your pi r squared h is equal to 2/3 pi r cubed. The next thing we're going to do is basically some cancelling down and having no fractions. So the first thing I'm going to do is divide both sides by pi, so they both cancel out. And then the next thing I'm going to do is divide both sides by r squared. So they're going to cancel, and that's going to cancel down to a power of 1. So we're now going to get h equals 2/3 r. To get this into a ratio between the height of the cylinder and the radius of the cylinder, I'm now going to times both sides by 3 to get rid of this over 3 bit here, to get 3h is equal to 2r. So the ratio between the height of the cylinder to the radius of the cylinder would be 3h to 2r. Okay then, the next question is over the page. And it says, given that y is inversely proportional to x, and that y equals 4 when x equals 3, find an expression for y in terms of x. So the key word here, if I highlight it, would be inversely proportional. The next thing to pick out is inversely proportional to what type of x, and it's just x. So we should know that that means we'd write it as y equals k over x. There is a line you can write beforehand, which is the proportionality sign, and it would be 1 over x, but that and that would still get you 1 mark. Okay, so you can skip straight to this bit. We're then told that when y equals 4, so when that equals 4, x is equal to 3. So I can go and put 3 in that place. So I can say as my next step, 4 equals k over 3. I'm now going to rearrange that by getting rid of the divide by 3. So I'm going to get a value of k, which is 12. And what I must do finally is write my formula, my new formula, which is y equals k, which we've just worked out is 12 over x. Okay, you must write this statement here. And that's going to help you work out these bits here. So here we're asked to find out y. So we know that y is equal to 12 over x, and they said when x is 0.25. Now, as this is a non-calculated paper, the quickest way to think of that is that x is a quarter, and then 12 divided by a quarter is the same as doing 12 times by 4. So y would be 48. So 48 is going to go there. And then for this bit here, this time we're told what the value of y is, which is 0.2. So again, I'm going to think of that as a decimal this time to help me. And that is k, which is 12 over x. I'm now going to rearrange, which would be x equals 12 over 0.2. And then I'm probably going to think of it again as a fifth, like they said there, and divided by 0.2 would be the same as doing 12 times by 5. So x would be 60. So 60 will go here. Next question, question 12. Have a quick read of it and I'll start to go through it. Okay, the way I always think of these when I solve them is an upside down ironing board. Now the way that this is supposed to help me, or what it's supposed to trigger me to remember to do, is that I cross multiply the numerator here with the denominator here. So I'm looking at these two guys. I'm also looking at doing exactly the same the other way around. And then, let's deal with the first bit. So we get 3x times by 2x plus 7. There's 2 bits, so I put it in a bracket. Minus 2x, bracket 3x plus 2. And then I put it all over one common denominator where these two are timesing by each other. So I'm going to have 3x plus 2 and then 2x plus 7. Now, in terms of our denominator, there's absolutely no need to expand that and simplify that. That's already in a nice simple form. If I expanded it, I'd only want to factorize it. Okay, so what I need to do now is expand the brackets. The number on the outside multiplies both of the numbers on the inside, but don't forget that this 2x isn't 2x, it's minus 2x. All of this is included. Okay, that's where you're most likely to make a mistake here. The first bit's easy enough. 3x times 2x is 6x squared. 3x times 7 is 21x. Then I've got minus 2 times by 3x, so that's minus 6x squared. So those two are going to cancel. And then minus 2 times by plus 2 would be minus 4x there. So you've got plus 21x, take away 4x. So that would simplify down to 17x as the numerator. And it would then still be 3x plus 2 and then 2x plus 7 there. Okay, next one. Okay, so we've got a question on what's going to be circle theorems, I would have assumed. So let's have a quick read. It says the points P, Q, and R all lie in the circumference of the circle. So this is a cyclic triangle, is what I like to refer to them as. And if we've got a cyclic triangle, it means we've got something called alternate segment theorem going on, which means this angle here that they've identified as x, this one here, that angle is the same as this angle here at P. And then similarly, this angle over here, which we don't know, they've not told us would be the same as this angle up here. Okay, so we're then told that the ARB is a straight line. QRB, which they've identified as x, where x is measured in degrees. Now we know this angle here is also called x because of alternate segment theorem. And it's absolutely fine to write on the diagram. I'll probably define it a little bit better later on as well, but I could just go and write alternate segment theorem there. I'll probably write it a bit neater afterwards. It's then asked us to calculate the angle of PQR, so from P to Q to R, so it wants us to work out this green angle here in terms of x. You must give a reason for each of your steps. So I need to know what this angle is here. So this angle here, we know is a straight line. That's 180 degrees. So this angle must be 90 degrees because the angle at the circumference is half the angle at the center. So that's 90 degrees. So I need to go and quote why that is as well. So I'm going to say angle at center is half angle at circumference. Okay. Oh, hang on, that's a lie. I've got it the wrong way around. Angle at the center is not half. This was the one at the circumference was half of the one at the center. Is twice. That's the opposite way around then. So the angle at the center, 180, is twice the angle at the circumference, which is 90. Okay. So if I go and explain what these angles are, so I'm going to say Q to P to R. So Q, P, R equals X degrees because, and I go and write in that, and then I can go and write in that P, R to Q equals 90 degrees because, except I'd actually write this bit out correctly this time. So therefore Q, and we want that to be in the middle, so P to Q to R, which is the one they wanted, is equal to 180 degrees. That's angles in a triangle. Take away 90 degrees and the X added together. And we can actually simplify that a bit further. 180 minus 90 would be 90 degrees, but we'd still need to take away the X. Okay, so it'd be 90 minus X. Over the page, we're told that Aled has 3 concrete slabs. 2 of the slabs are in a square. Each has side of X meters. I always like to try and draw these out to get my head around what's going on. So we've got 2 squares, so X and X. X and X are obviously the same size. The third slab is a rectangle that measures 1 by X. Okay, so we don't know how long X is. So if that's X again. Oh, hang on, I've not written that rightly. So that's 1, and then this is X plus 1. Okay, we're told that the 3 slabs cover an area of 7 meters squared. So this area we know would be X squared. This area would be X squared. This would be 1 times by X plus 1. And we know the total area comes to 7, so we can say that X squared plus X squared plus. So we know that this area, X squared plus this area, so 1 times by X plus 1, must come to a total of 7. So from here then, we can say that's X squared, so that's 2X squared that we've got, plus, and then that just expanded out, anything times by 1 stays the same, so that's be X plus 1 is equal to 7. Now take away the 7 from both sides, gets me 2X squared plus X plus 1 minus 7 would be minus 6 is equal to 0, is equal to nothing, which is what they wanted there. So I've gone and shown that's the same thing. We then want to solve the equation. So to do this, we need to factorize this quadratic. So to do that, I'm going to multiply the first and the last term together. So 2 times by minus 6, which is minus 12. And I'm looking at the middle number here. So the number that would come in front of that x, which would be 1. So I'm looking for 2 numbers that times together to give me a minus 12. So that tells me it has to be one of each sign. I'm going to write down a couple of those. The chance I won't get them straight away. And they add up to plus 1. So pairs of numbers that times together to give 12. So 12 times minus 1 will give me minus 12. But 12 take away 1 is 11. So that's not my pair. So let's try 6 and 2. No, that's 4. So that's not my pair. So let's try 4 and 3. That's it. That's 1. That's plus 1. That's my pair. Okay, now the way that I factorise this from here, don't need that last combination, is I drop just the squared and I write 2x in the front of each bracket. And then plus 4 goes in one, and then minus 3 goes in the other. Now, if you use my method, you must cancel down any of your brackets that can be. These are both have both a multiple of 2, so we just literally halve both of those. And then once that's been factorised down, that should be the correct one. So let's just double check. 2x times x gives me 2x squared, plus 2 times minus 3 gives me minus 6. So my answers are either x equals minus 2 or x equals 3 over 2. So it's just solving those individually, putting x plus 2 equals 0 or 2x minus 3 equals 0. So taking the minus 3 over plus 3 divided by 2 to get the 2. Now, if they're slabs, if they're like measures of a slab, there's no way it can be a minus measurement. So it can't be that because, so say can't because of negatives. So x equals 1.5. Okay. Okay, the next question says, the diagram shows a sketch of f of x that passes through the following points. It then wants me to draw the graph of f of minus x. Now, sorry, f bracket x minus 3. Now, if I'm ever asked to do these things here, the method that I use, that if it's inside the brackets, you do the opposite of what it expects to x, okay? So rather than taking away 3 on each of the x coordinates, I want to add 3 to each of the x coordinates. So minus 1 on the x there, added 3 is now going to go through 2, 0. So I'll go and make that point there as 2, 0. That's now going to go through a high point of adding 3 to that would give me 5, 7. And then adding 3 to that would give me 8, 0. So it's got to go through those points, and it's got to look the same type of graph there. And then I'll just go and make the point there, that's 8, 0. And it's expected that you write all of those coordinates in. The next graph asks me to draw the graph of cos x plus 1. Now, the first thing that I would do is underneath, I'm just going to sketch what cos would look like ordinarily, and then I'll transfer it. I'll transform it afterwards. So cos, I always look at the cos graph and think, oh, well, that O in cos looks like a 0, but ironically, rather than going through 0, it goes through 1. It starts at 1, the cos graph, and it looks like a letter C. Doing that, and then it will go down and do that sort of shape. And the values you need to know is 90. It will reduce down to the x-axis. Then at this point here, which would be minus 1, that would be 180. This would be 270. So then to get up to 360, we just repeat like that. Okay, so basically this graph here, I now want to shift up 1 because after it, I'm plussing 1 to the values. Okay, so where it goes through the y-axis would now be 2. At 90 degrees here, go through half of that, go through 1. And then sort of same distance there, 180. It's not going to go through minus 1 anymore. It's going to get shifted up to being 0. And then at 270, it'll be back to 1, same place as the 90 was. And then at 360, it'll be back up to 2. Okay, so it's going to look something like this. Okay. Over the page, question 18, quite a fussy question I thought, page 18, question 16, quite a fussy question this one, I didn't think this was easy to write out. It says, triangle ABC is an isosceles triangle with angle B equal to angle C, okay, to A to B to C is equal to A to C to B, okay. So the points P and Q are on AB and AC respectively. So the AP, so I'm going to actually highlight that, AP, this line here, is equal to AQ. It's equal to that line there. Now, prove that ABQ, so A to B to Q, so this whole triangle here, or best highlighting I've done, prove that this angle is congruent to A to C to P, to this one here. Okay, so an awful lot of highlighter going on there. Maybe it's too much in some respects. So basically this one here, I've flipped it over, it should fit on that one. Okay then, so the first thing I'm going to say is that this line here, A to B, has got to be equal to A to C because ABC is an isosceles triangle. So I'm going to say AB is equal to AC and AQ, well, we know AP is equal to AQ as well. I'm just going to go and say why that's the case. This is because it's an isosceles triangle. Now that's done pretty much the whole battle here because it's an isosceles triangle. Now from here, we've got this length here, which is the same as this length here. And then we know that these lengths here are the same. So if I was to look at this length here, this triangle here, and I took this other one out, so I drew it there, to prove that it's isosceles, well, I know they're the same, and I know that these guys are the same as well, and they share this angle at the top here. So it's all the devil's in the detail of the next one, okay? That's basically what we've got if I separated those two triangles out. So I'm going to say it means that ABQ and a CP must be congruent, and it's all because this line here and this line here are the same on both, and they meet at the same angle. So that's how we have to word it, okay? So we say because side, and then it's not good enough to just say angle side. You have to include a really important word here, which is included angle, okay? If it was this angle down here or this angle down here, it wouldn't matter. Those two sides we know are the same, okay? So that's what the definition is. Now, over the page, we've got the very last question, I think. Just double check. Oh, no, there's one on the other side as well. Okay, so question 17, it says simplify the following thing, which is third. So to do that, it says state whether your answer is rational or irrational after simplifying that. So you've got to do these individually. I'm going to do these individually to work them out, okay? So I'm going to do that bit by itself because it's squared. That means I've got to do bid mass. I need to simplify that bit first as well, and I need to simplify this bit here, okay? So I'm going to do all three of those separately, and then I'm going to tie it back together as being a fraction. Squared means times by itself. So 5 root 3 squared means 5 root 3 times by 5 root 3. 5 times 5 is 25. Root 3 times root 3 would cancel out just being 3. So 25 times 3 is 75. 2 root 18 divided by root 2 can be written as the following, using your rules of surds. 18 divided by 2 is 9. So that is 2 root 9. And then the square root of 9 is 3. 2 times by 3 is 6, okay? So I now know that bit 6, although I have written that mathematically very badly, as you're not supposed to write equals all on one side, but I know I'm going to run out of space otherwise when I'm showing this to you. And then finally, root 32 times 2, root 2, sorry, that's probably the easiest of the lot. That's root 64, and the square root of 64 is 8. So I can rewrite that as 75 minus 6 divided by 8, which I can simplify again to 69 divided by 8. And there's no need to simplify that down, even if it as it doesn't ask me to simplify it down, but I do need to go and state it's rational or irrational. Now, the definition of being a rational number is being an integer, a whole number, over another integer, which this is. This is a whole number, 69 over another whole number. Even if it's 69.5 over 8, it's just double top and bottom, okay? So I'm going to say, so rational. Okay then, over the page, we've got our last one here. It says, a game is played at a children's party involving throwing a ball into a bucket. Each child tries to get the ball into the bucket in the least number of throws. On one attempt, the probability that Sophia gets the ball into the bucket is 0.8. Each attempt is independent of any previous. So basically that means it will always be 0.8 for Sophia. It doesn't mean that just because she worked out how to do it last time, she definitely knows how to do it this time. Show that she is 5 times more likely to get the ball in the bucket on her first attempt than to get her first successful throw on her second attempt. Okay, so she's got a 0.8 chance of getting it in on the first throw. If she was to get it on her second throw, if you think about it, I'm going to do it as probability trees. So she gets it, doesn't get it. That's my first option. Now, there's a 0.8 chance that she gets it on the first go, and then there's a 0.2 chance that she doesn't get it. Now, in terms of that, if she got it, then on her first go, that would equal 0.8. If she doesn't get it, she's going to throw again, and then she'll either get it or she doesn't get it. And that would be her second attempt. So the chance that she'd get it would be 0.8. Chance that she didn't get it would be 0.2. And we're asked to go and show that she is more likely to get it than her first successful throw than her second attempt. So her second attempt would be that she didn't get it then, and then she got it to get a successful first success the second time. So that would be 0.2 times by 0.8, which is 0.16. And what I need to do now is show that that is 5 times more than that. So I'm going to say 0.16, 0.32, 0.48, 0.64, 0.8. Okay, so I'm going to then say 0.16 times 5 equals 0.8. So she is 5 times more likely. 5 times more likely to get through on the first attempt. Okay, I hope that was useful. If it was, please hit the subscribe button and you'll get access as and when I release any more videos. Thanks very much for watching.